How can I use the Pythagorean theorem to find side lengths?
I ask that question a lot. Except why do I use it?
In triangles?
Or why do we learn it?
How can I use the Pythagorean theorem to find side lengths in triangles? All right, the Pythagorean theorem is a squared plus b squared equals c squared for all right triangles where A and B represent the legs and C the hypotenuse. All right, you guys are all going to need a calculator today, so go get your calculator. You're not going to write You're not going to write anything down there, Sparky. Hey, Sparky. And then turn your calculator on and make sure that it is set to round 2 decimal places. Second fix 2. Fixes period button.
The dot.
If you turn it on and it says 0.00, then it's set for 2 decimal places. Second fix 2.
Actual 2.
Second dot 2. Hey,
Okay?
He said no.
my head hurts. Thanks. My birthday is
Well, happy early birthday.
Yeah, it is.
All right, be quiet. All right, so look, in a right triangle. Sit down, please, and be quiet. Sit down, please, and be quiet. What?
He said I'm only 16.
The calculator said press, like we turn it on, we press second, fix, and then 2.
Yes. No, Carol. In the second, the dot.
I know, I'm just making sure that's what I did. Yeah. If it
It's-
says 0.00, then you fix it.
All right. If you're given a right triangle and you're given 2 of the side lengths, in this case, you're given the 2 legs. First step is to label the sides of the triangle. You're going to label the sides that are next to the 90-degree angle, A and B. Those 2 sides are always A and B. The legs are always A and B. The side opposite the 90-degree angle is always C. The hypotenuse is always C. So you know the formula is a squared plus b squared equals c squared. 9.3 squared plus 4.7 squared equals c squared.
Why does it have those little things in parentheses? Yeah.
Now, type 9.3 in your calculator and then hit the x squared button. Hello?
Second degree.
All right, so you got 86.49 right here. 86.49. Shh. Plus, take 4.7, type it in, and hit x squared. It's 22.09. 2 above the 8. 2 buttons above the 8 equals c squared. Now, the 2209 is still sitting in your calculator, so hit plus 86.49. And 108.58 equals c squared.
It equals 108.58.
The next step is to get rid of the squared that's next to the c. And you do that by square rooting each side. Because the square root of c squared is equal to c. And while this is still sitting in your calculator, there's a button to the right of the x squared that shows the square root of x. If you push that button, it'll find the square root for you.
Wait, say that again.
10.42.
Push the button next to the x squared.
There's a radical button right next to the x squared. That way you don't have to type in any more numbers. 10.42. Clear?
Yes.
That's when you're finding the hypotenuse. This is what you're doing today. Do you need to see an example of finding one of the legs? Because then you have to subtract.
Yeah.
Okay. So, take another right triangle. Let's say your side lengths are 20.6 and 11.8. First step is to label the sides. So next to the, adjacent to the 90-degree angle, or the legs that make up the 90-degree angle are your A and your B.
Does it matter which one's A and which one's B?
No, it doesn't matter. The one opposite the 90 is the hypotenuse. It's always side C. So now you got A squared plus 11.8 squared equals 20.6 squared. So A squared plus 11.8 square root button. 139.24. Equals 20.6 x squared, or 24.36.
16.
Shh. 20.6, and then hit the x squared button. 2 above the 8. You got the 139.24? Well, then I squared the 20.6. Now you got to get the A by itself, so you're going to subtract 139.24 from each side. And you've still got that 400 number sitting in your calculator. So push minus 139.24. 285.12. And again, you have to get rid of the squared, so you find the square root of each side. The 285 is still sitting in the calculator, so you hit the square root button, which is to the right of the x squared. 16.89.
This is really easy.
Now, if you'll remember this Pythagorean theorem, and you'll use it more often, almost every distance problem on a standardized test, you can use the Pythagorean theorem instead of the distance formula. It's way easier to work with. Okay? Any questions?